I never thought I'd be making layout lines like these, but here I am. And I gotta say, it's much faster than scribing them, and still reasonably accurate. Lately, I've been modeling a lot of the stuff I find a bit more complex to make. It helps me visualize problems ahead of time, and sometimes, when there are several parts involved, I just go ahead and 3D print them. That way, I can get a better feel for how the parts are going to work together. And when the machining time comes, it even helps to break down the order of operations. The other tool I've been using lately, before machining, is this fiber laser. I've been generating 2D views from my models, which is something really simple to make in Fusion 360, and then I just use the laser to mark the layout lines on the stock. It adds a couple of minutes to the process, but makes it much less likely that I'll screw up on something simple, like forgetting to account for the edge finder diameter when locating a hole, or going over a dimension when I'm roughing. The market seems to be flooded with different types of lasers right now, but a fiber laser is the one you want to have if you're looking to engrave metals. Steel, stainless steel, aluminum, brass, and even copper. None of these seem to be a problem for this fiber laser. And these are not just surface markings, they're actually deep, and we can make them deeper by running more passes. So this laser was provided to me by emsmart. It's their basic model, called Basic 1R, and I've been using it for about a month. I agreed to make a video to showcase what I've done with it so far, and this is that video. Just to be clear, I'm not being paid to share a certain opinion or tell specific things about this laser. Everything I say in this video reflects my own current point of view. So let's start with the fact that this is the first fiber laser I've ever used or even seen in person. For that reason, I won't be able to compare it to others on the market, but at the same time, I can give you an idea of what it's like to get started with the Basic 1R, with zero experience in fiber lasers. My first impression was, this box is heavy, but actually this is one of the lightest fiber lasers out there. Opening it revealed a very well packaged machine, but I'll get back to the packaging later. The laser comes pre-assembled, and all I had to do was bolt down the column and the laser head. All the joints are labeled to make it clear what goes where. A pleasant surprise was to see threaded holes in the laser's bed. I saw them in the pictures on emsmart's website, but I wasn't sure they were tapped. I think it makes a lot of sense and opens the door for proper, repeatable fixturing. The build quality of the machine looks fine to me. It definitely doesn't feel cheap, but I can compare it to other fiber lasers out there. Like I said, the whole thing is surprisingly heavy, but in a good way. It feels solid. The fiber cable, however, running from the source in the base to the galvo system in the head, it feels a bit awkward. I say awkward because it's bulky. It doesn't and really shouldn't flex much, but just makes the whole thing larger. If you don't want to position the laser sideways, as I did, you'll need a deep table. Speaking of the galvo system, the way these lasers work is different from the typical diode and CO2 lasers. While those have the laser head moving on a motorized gantry system, a galvo laser like this fires the laser from a fixed position through a pair of mirrors. These mirrors, mounted square to form both axes, are driven by very fast motors. That's how these lasers achieve very high engraving speeds. However, being in a fixed position also limits their working area. And then there's a lens in front of the mirrors, which can support either a smaller or larger working area. The smaller it is, the finer the details that can be engraved. The Basic 1R comes with a medium-sized lens, which has a working area of 110 by 110 mm. One thing I didn't know until I received the machine was that galvo lasers are not controlled through G-code. So the Lightburn G-code license I have for my diode laser, it didn't work here. The Basic 1R ships with a USB drive containing EasyCAD 2, which is the free software you can use to control the laser. But the emsmart lasers also support light burn. I prefer light burn and was glad to see that the basic 1R supports it, something that not all fiber lasers on the market do. That said, I had to buy Lightburn's Galvo license. Luckily I got a discount since I already had a G-code license. On a side note, emsmart also sells Lightburn licenses, so if you're looking to get one, go check them out. So with the software installed, I jumped right into engraving an image on a business card. I don't recall the exact settings I used, but the card started to melt and I had to stop the job immediately. It still left a tiny mark on the laser's bed though. That made me realize I'd better protect the bed before I actually engraved something on it. I had a 12mm piece of aluminum that looked perfect for a fixture plate, so I made one. Meanwhile, I ran more tests and noticed that my engravings were coming out larger than they should. To resolve that, I followed an awesome YouTube video that explains how to calibrate the lens. I'll link that video below. It's not something difficult, just a bit tedious. You start by trying to engrave a square, which probably won't come up as a perfect square, and then make adjustments until it does. Every time I want to engrave something, I need to focus the laser. Some lasers have an out-of-focus function, but not this one. I need to do it manually using 2 red laser dots as a guide. When the moving dot converges into the fixed one, the laser is in focus. The problem is that I find it difficult to see the 2 dots when they get really close. So instead, I'm using this tool. This was 3D printed and works like a filler gauge. This way I don't have to pay attention to the dots. With the lens calibrated, a new fixture plate and an easy way to focus, I started experimenting with engraving still. Lightburn has this cool feature that creates test grids for us, so we can try different parameters for our material. While power and speed are straightforward, these lasers add a third variable that highly affects the engraving: frequency. Frequency relates to the pulses per second of the laser. That means a lower frequency has fewer pulses per second, but then each pulse is more powerful than at a higher frequency. Think of it like distributing the same power over a different number of pulses per second. Here's the effect of adjusting frequency alone on a piece of stainless steel. The first grid is 20 kHz, the second 40, and the third 60, which is the maximum this laser can achieve. MOPA lasers can go much higher. Unfortunately, this isn't a MOPA laser. Still, we can play with it and increase the frequency to apply less heat to our parts and, for instance, engrave plastics. This is a piece of PLA, which is 3D printed, and here's a sample of PETG. In both cases, the laser is just removing the pigment from the plastic, so this only works for darker colors. Another thing we can do is clean up passes. Those are low power, high speed and high frequency passes. You can even remove surface rust with a cleanup pass. Another use for this laser is, of course, marking tools. Here's a carbide end mill engraved with a 2.5mm font size. I tried going smaller to the point where I couldn't read the text, and here's that view under the microscope lens. So after adjusting the timings, line height and dot width, I was finally able to engrave an image on a business card. I've seen others achieve better results, so I think this is just okay. Probably I could get better results if I had more experience playing with the settings. Custom shipping boxes is another cool thing you can do with a laser. Just be careful with cardboard, as there's a fine line between a fire and a wick mark. But if you want to take packaging further, EVA foam is really easy to work with. The problem with EVA is the fumes released when it starts to burn. The same goes for other materials, like the aluminum business cards. That's why good ventilation is really important when working with lasers. I don't have any windows in this room, just a couple of openings to the outside, so I'm already working on adding a ventilation system. Meanwhile, emsmart sent me this air purifier. It's basically a box with a fan and some filters. I was skeptical at first, but I must say it works better than I expected. Here's a bad experience with PLA, where I was clearly burning through the plastic. As you can see, most of the smoke is being sucked into the purifier. So I kept using it, and I have to say it does make a difference. However, like I said, I'm not relying on it alone to protect my lungs. One thing I should mention here is the build quality of this purifier. It doesn't feel like a cheap, mass-produced product at all. Even the latches feel premium, they're really smooth, and the powder coating is very good, inside and out. It matters to say that emsmart also sent me an enclosure for the laser, and that does seem to work and block the radiation. However, because the whole thing is black, I couldn't get any good shots for the video. That's why I'm not using it right now. Putting it together wasn't a big deal, but I did have to trim down the rear panel to make it fit. And then add some screws to hold it in place. Maybe it was supposed to fit bowed like these, but I didn't like it, so I did it my way. I also got an extra section of this lock line clone, just so that I could have the purifier on the floor. I think I was supposed to route the purifier pipe through the hole in the enclosure, and I tried that, but the pipe doesn't bend enough and always gets in the way of either the focus handle or the workpiece. So I 3D printed this adapter to attach a short length of the lock line. The rest of the lock line? Well, I extended the extractor pipe and now the box can sit on the floor. By the way, these adapters and the focusing tool are available on my Patreon, along with the other tools you see on this channel. If you're interested in them or just want to support the channel, the direct link is in the description. Before we get into the rotary, let me quickly tell you about the packaging. All these boxes were very well packed, which again doesn't give off that cheap product feeling. At first, I thought some of the enclosure acrylic panels were broken, but they weren't. Besides a lot of bubble wrap, all of them had these plastic corner covers, which gave their lives to protect the parts. It's a small detail, but it clearly makes a difference in how the product reaches the buyer. Okay, let's talk about the rotary. Of the entire machine and accessories, this was what surprised me the most, quality-wise. For what it is, it looks and feels impressive. It's definitely on a differently compared with the rotary for my diode laser. What this accessory does is enabling the engraving on round surfaces, and since I have a lathe that produces round parts, a rotary is like a must-have for me. And this is the time I should bring your attention to the fact that if you think you'll need to use a rotary, and you're planning to buy one of these lasers, of course, you should get one of the R models, like the basic 1R. While the basic one looks like the exact same machine, just without a rotary, that doesn't have the port to control the rotary. So watch out for that. You can't just buy the rotary afterwards and expect it to work. The only thing you'll need to know to set up the rotary is the steps needed for the motor to make a complete revolution. That's something I didn't find anywhere, so I went trial and error. 25,600 seems to be the number. At least that's what worked for me to get this dial perfect. And here's a direct comparison to the one I made with my diode laser. At first the diode engraving looked better, but a cleanup with fine Scotch-Brite wiped off part of the markings. I did the same with the fiber laser dial and nothing changed. This looks like a much more durable engraving. And this is what I've been up to with this fiber laser. While I'm not used to work with lasers, I didn't find it difficult to get started, and I'm already planning on using it on a future project that I have in mind. If I had to list some improvements for this 20-watt model, I'd say to slow down or shut down completely the fans when the laser is not in use. It's a bit annoying to have them running all the time. On the other hand, the laser can be turned off and on really fast, as it doesn't have any startup time. So there's a workaround. The laser worked flawlessly in all my experiences, and I find the preview framing of these galvo lasers refreshing, much better than having just a contour like in my diode laser. As for the price, if you'd like to add one of these lasers to your shop but find the price a bit steep, make your investigation and then have a look at the links in the description. With the Black Friday coming up, this might be the right time. And that's all for today. In the next video, we'll be back into machining.